Hello and welcome to Team 10's senior project presentation, a cold rolling mill sponsored by Grand Valley State University. Our team was comprised of Nicholas Fiore, Nicholas Erickson, Austin Blumenthal, Andrew Mitchell, Trey Pfeiffer, and Michael Verweis. The problem posed for Team 10 senior project was that Grand Valley State University's engineering program currently lacks the equipment necessary to experiment with cold rolling, which is a subject in EGR 250, Materials Science and Engineering. To this end, a cold rolling mill had to be designed and constructed, which would allow students to gain hands-on experience with cold rolling processes.
The constraint specifications for this project are that we were given a budget of $5,000 by Grand Valley. Sample material to be used was a 1/4-inch thick piece of cartridge brass of approximately 3 inches in length. The goal was to reduce the sample thickness by 50%. The cold rolling mill assembly was also to be made mobile as it was unsure of exactly where this product would be used. An emergency stop flap was incorporated into this design to provide an easy access to an emergency stop button in case anything goes wrong. A push slider was also incorporated to protect the user's fingers from being inserted into the crushing forces of the rolling mill. These are two pictures of the CAD of the final plan assembly of the cold rolling mill. On the front of the machine, you can see the emergency stop flap. On the top of the machine, you have the operator push buttons, the mill itself, and the push slider assembly.
For the performance of our rolling mill, we are currently in the testing phase, checking both the mechanical and the electrical systems of our machine. We've been able to roll previously hardened cartridge brass to 25% thickness and are looking for sourcing annealed brass to test it further. Additionally, we are comparing mathematical calculations that we devised to the real world results that we were getting. And then we are also looking into roller lubrication to prevent warping of the test sample. And finally, paneling will be added once the testing is completed. One of the biggest design challenges was the coronavirus pandemic. It led to greatly increased lead times for many of our components and materials. Thus, we had to construct things out of order in order to prepare them for when the newer components would come in. Additionally, there were many increased costs for some of these components. Thus, we had to search across for many different sellers to find the best option. The Durston CAD, which is our rolling head, was unavailable. This became a problem when the manufacturer gave us incorrect shaft diameters, which led to the purchase of the wrong shaft coupler that we needed. Thus, we had to construct a new key for the current shaft and purchase a cheaper coupler alternative to make sure that it still worked.